In these problems, we're told that the Precision Scientific Instrument Company manufactures thermometers that are supposed to give readings of 0 degrees Celsius at the freezing point of water. Tests on a large sample of these thermometers reveal that at the freezing point of water, some give readings below 0 degrees and some give readings above 0 degrees. So we're going to assume that the mean reading is 0 degrees Celsius and the standard deviation of the readings is 1 degree Celsius. So I've set up 3 normal distributions here at the bottom, all with a mean of 0 and standard deviation of 1. And a thermometer is randomly selected and tested. We want to find the temperature reading corresponding to the given information. So in question 10, we want to find the 96th percentile. So what I want to do is estimate about where the cutoff would be. So I'm trying to guess what value this would be if we have 96% of values below that mark. So right here, this is my 96th percentile. So to calculate this, I'm going to use inverse norm because I have the percentage and I want to find the data value that corresponds to that. So I have the percentage on the left, which is 96%, and the mean is 0 and the standard deviation is 1. So when I put this into the calculator and I round to 2 decimal places, I get 1.75. So this is about 1.75. And that makes sense. That looks like about 96% on the left. And so, of course, if we were to say what percentage is in the tail, that would be 4%. They didn't ask that in this question, but that's what that would mean. Now, in the next question, we want to find the third quartile. So that's the cutoff for the bottom 75% of values. So that's going to be roughly here. And we're going to say 75% on the left, 25% on the right, and this value is Q3. So the question is, how much is Q3? And it looks like it's between 0 and 1. So let's take a look at what happens when we put this into the calculator. So I'm going to use inverse norm, and 75% is on the left. Mean is 0, standard deviation 1. Now remember, for most calculators, you have to give the area on the left, or the percentage on the left. There are some calculators where you can do that a little differently. So if you have the percentage on the right, what you can do is say that that percentage is on the right. So certain calculators will do that. You have the choice to choose left, right, or center. But if you don't, then you always have to give the percentage on the left. So in this one, our percentage on the left is 75%. And when we put this in and round to 2 decimal places, we get 0.67. Now let's take a look at number 12. In this case, it says 9% of the thermometers are rejected because they have readings that are too high. So this is a case where we're given the percentage on the right. And so I'm going to estimate that 9% probably cut off somewhere around here. Let's say this is roughly 9%. You don't have to be precise with that. because that's what we're trying to find. We don't know what the cutoff value is for that, but we just roughly estimate that. And if we have 9% on the right, that means 91% on the left. So I'm going to do this just like I did the last two. And I'm going to put in the percentage on the left. Mean is 0, standard deviation is 1. And when I do that and round to 2 decimal places, I get 1.34. So that looks about right. So the other option with that one would have been to do inverse norm 0.09, 0, and 1, but then you have to say that it's the area on the right. So you may or may not have that option on your calculator. If you do and you want to use it, that's fine. Otherwise, just go with inverse norm of 0.91. And that's how you do those problems.